So hi guys, and welcome to our talk on Blazor. Blazor is this new technology by Microsoft that is supposed to enable developers to do full stack web development using only C#. Not surprisingly, Blazor is based on .NET. Having C# involved, it would be quite surprising to be different. So let's move on. Some talk metadata. The target audience of this talk would be web developers, of course, because this might be a game changer for them, and also .NET developers, because as we said, Blazor is based on .NET, so if you already use .NET, then you get like a huge new skill for free. You can do client-side web development without learning new technology. So the scope of the talk, we're going to figure out what Blazor is. We're going to have a quick look at the inner workings, or maybe not so quick. We're going to check out some use cases. We're going to look at Blazor's performance. And of course, then we're going to sum up with advantages and drawbacks of Blazor. Why am I giving this talk? I mean, yeah, I was already kind of introduced. I altered a number of .NET developer tools. I did a decompiler, mocking framework, web debugging proxy, whatnot. So I spent almost a decade maintaining those. So I have, let's say, above average .NET internals experience. Blazor being a .NET technology, it's kind of, let's say, natural choice for me to talk on something like this. So enough metadata. Let's jump to Blazor. So as we said, Blazor is a web development technology, and let's try figuring out what problem they're trying to solve here with Blazor. So the current state of web development is there are plenty of technologies to choose from. It's like standards. Good thing about it is there is so many to choose from. So on the server side, there is like real abundance. There is .NET, Java, whatnot, JavaScript, Ruby, Python. This list is probably longer than the slide. The client side tends to get dominated by JavaScript and TypeScript, but there is an abundance of frameworks there on the client side. So as a result, usually server-side and client-side development are done by different teams. This naturally involves some duplication of effort. Same functionality has to be implemented in two different technologies, stuff like validation and whatnot. So this whole thing is quite inefficient. The client-server communication usually goes through some kind of serialization because you have different technologies on both ends, which kind of adds inefficiency. Of course, there are technologies like GraphQL that would solve this problem, but it's just like also one more technology to add to the technology stack. So this is where web development currently kind of is, and Blazor is, let's say, designed to come in as a game changer on that scene. So what Microsoft is offering is single technology for the client and the server side. That technology is already mentioned is .NET. Same code can be ran both client and server side, so you can easily switch between client and server side execution, and IDE support is traditionally good with Microsoft. So let's take a deeper look at this. So what Blazor is, it's a .NET-based single-page application framework. Pretty much it's heavily based on something called Razor. It's a template markup syntax. Even the name of Blazor comes out of this. It's like browser plus Razor. It's like running Razor in the browser. Blazor, they added this L because I guess it sounded better. So having this in mind, then let's check out what Razor is. I mean, there is a good chance a lot of you guys already are familiar with Razor because it has been around for like a decade almost now. It's a syntax combining HTML and C#. So it's like you write a web page, the static parts are HTML markup, and then dynamic functionality is implemented in C#. Somewhat surprisingly, normally when I have something like this and it gets compiled to HTML JavaScript only. With Razor, it's the other way around. HTML gets compiled to C#. Pretty much C# codes get generated that when executed will generate equivalent HTML. So in essence, you end up with C# code generating HTML. So Razor, as I said, has been around for like a decade, and so far it has been used on the server side. You can see how this works really nicely. You have a .NET web server, it executes some C#, that generates HTML. The HTML gets sent back to the client. The client-side browser displays this HTML, and everybody is happy. So let's have a quick look at Razor syntax. What we see there is Razor sample. What we see at the top is the actual Razor code. As you see, it's mostly like regular HTML with this not even proper C#, the page directive on top. And then what you see at the bottom part of the screen is actually the compiled Razor. As you can see, this is pure C#, and you can easily see how, when executed, this thing is going to actually end up generating this HTML on top. So now, having this in mind, we said that Blazor actually allows you to run Razor in the browser. So let's see how all this works out. So actually Blazor does much more than that. I mean, it has a couple of hosting models, which means you can execute the Blazor application in the browser. You can execute it on a server environment. This is Blazor Server. Executing it in the browser is currently called Blazor WebAssembly. Since this Blazor is fairly new technology, this got renamed a couple of times. Latest name is Blazor WebAssembly. And there is a mixed execution mode that allows you to execute part of your C# Razor application in the browser and part of it on the server. So let's start with Blazor WebAssembly, because this is really the game changer. This is what allows you to execute C# and Razor in the browser. So let's see how this all works. It's based on two technologies, WebAssembly and Mono. You have greater chance to be familiar with Mono. WebAssembly has been, let's say, not that well known so far, but it's pretty cool technology. We'll have to take a short look at both of those to figure out how everything works. So let's start with WebAssembly, because WebAssembly is really instrumental to Blazor WebAssembly, as the name shows, and it's really instrumental to running C# in the browser. So WebAssembly is an open standard. It's not like an invention of some of the big companies. There is no single big company behind it. It's just a standard that specifies a format for portable executable, assembly language, and ways to interact with the host system. So far, it's just like generic standard. In theory, you can run WebAssembly anywhere, but it was created with the primary purpose to be executed in the browser, allowing high-performance applications to be run in the browser. So it's really aiming at bringing performance to the browser. It's not aimed at replacing JavaScript in the browser as of yet. It's more like it works together with JavaScript. Currently, it doesn't even offer direct access to the document object model. So JavaScript still is necessary, let's say. So it's also not really intended for direct use. You're not supposed to write programs in WebAssembly assembly language. But yeah, it's mostly compilation target for other languages. So you're supposed to be compiling something to WebAssembly assembly language and then executing it in the browser. We already said it does have really good JavaScript integration, and that's how you can achieve the full functionality. So let's just take a short diversion and check out how the assembly language looks like. Hopefully none of you will ever need to do that, but yeah, what should be mentioned about it is just like doesn't use addresses. The memory is organized as a stack, so whenever an instruction needs to do something with the memory, it's always the top of the stack. Instructions pop the top of the stack or push results at the top of the stack. This approach simplifies some stuff. You don't really have to take care of addresses anymore. So that's how they end up with pretty efficient WebAssembly execution virtual machine. So what is the current state of the browser support for WebAssembly? Actually, WebAssembly as open standard was initiated by the big four in the browser world. It was initiated by Chrome, Firefox, Safari, and Edge. And they ship with WebAssembly support ever since 2017. There's public data on the web that suggests that 9% of all the browsers currently in use support WebAssembly. For those that don't, there is a polyfill alternative in JavaScript, but I mean, as expected, it doesn't really improve performance. It just allows you to run WebAssembly on legacy browsers. So now that we know what WebAssembly is, let's have a quick look at Mono. So Mono is actually the actual link between the .NET world and the browser world. WebAssembly gets used in that, but Mono is the step towards .NET. So Mono is a flavor of the .NET framework. It has been around for quite a while, so probably some of you guys are familiar with it too. It actually started independently from Microsoft, and it was aimed to bringing the .NET framework on a bunch of different platforms. This was at the time where Microsoft .NET framework was running only on Windows. So Mono started with the idea of multi-platform support, which is one of the reasons it was chosen for Blazor. And then the other reason is Mono is actually the basis of Xamarin. This is a more popular technology. So Xamarin is a technology that allows programming in .NET for Android and iOS. And Mono being involved in this, Mono ended up having this, let's say, quite unique linker for the .NET world. So if you, let's say, your application is referring a library that has 1,000 classes in it, but you're using just one of them, then the Mono linker is going to actually cut the unused classes, thus shrinking the size of the application. So this apparently is very useful in the mobile world, and you can see how it can be useful in the web world too. So this is why Mono got actually chosen to it got chosen for Blazor. This is why Blazor got based on the Mono flavor of the .NET framework. So now, having Mono and WebAssembly, we can kind of see how .NET is going to be coming to the browser. If we can run Mono in the browser, then we have .NET in the browser, and WebAssembly is the instrument for running Mono in the browser. So surprisingly, there is no direct compilation path from C# to WebAssembly yet. WebAssembly doesn't support garbage collection and a lot of other stuff. But luckily, Mono runtime is actually implemented in plain C, and plain C can be compiled to WebAssembly. So once you do that, you actually end up with a .NET framework running in the browser. And this is what Blazor WebAssembly uses to bring .NET to the browser. So here's how the whole thing looks like. You start with Razor source, which is mixed HTML and C#. Razor gets compiled to pure C#. So first compilation change is you get pure C# that when executed is going to generate HTML and JavaScript. Then you run this pure C# through the C# compiler, and it generates a .NET standard library for you. And this is what happens on the development side. Above the line, this is what happens on the development side. So you end up with a .NET standard library that contains code that when executed is going to generate HTML. And then you feed this library to the browser. You feed literally the .NET DLL to the browser. And in the browser, you have the Mono framework compiled for WebAssembly. This is the Mono WASM. And it can execute your C# code that generates HTML and display it in the browser. So this is how Razor web pages get executed in the browser. And now we can actually let's try a short demo. Let's see how this actually happens. Supposedly it's gonna be worth more than 1,000 words. So no, you guys don't see this. Okay, just a second. Maybe. No. Why would that be the case? Nope. That's a bit weird. Okay, let me try just closing this. Okay, now you see it. I'll have to reopen it later on. So here is a Blazor WebAssembly project. Actually, now when you try creating an empty Blazor project, you end up with sample code. Blazor is still in half experimental state, so maybe this is why this decision was made. So let's see what this application actually does. It's a pretty simple thing. It has a couple of pages. Hello world page. There is this counter page that you have a button. When the button is clicked, counter changes. And you have a page that brings some data from a mockup web service. So far so good. I mean, it looks like pretty standard web application until we actually look at what happens behind the scenes. So when we load this thing in the browser, what we see is we see some CSS code, we see a JavaScript, some JavaScript infrastructure being loaded there, and then all the rest is we see Mono WASM that we said is going to be there, and then those are standard .NET DLLs, and they get loaded to the browser. So Blazor WebAssembly DLL, this is the actual application, the actual library that contains the Razor views, and the rest are dependencies. The rest are the dependencies of this library, and this is literally .NET DLLs getting executed in the browser. The really cool thing is there is actually even debugging support for that. Did we lose something again? Probably, hopefully no. So you need to start Chrome with a different set of parameters. Let's just take the address. Debugging works only in Chrome so far. It's still in preview. I really hope it's going to work and you guys can see it. So you do this, and then in order to start debugging, there is the magic keys that for some reason don't work now. Okay, Shift Alt and D. No. So maybe this ain't gonna work. No, wait, it is gonna work. As I said, it's still in preview, it's still experimental. So now this is really experimental debugging view in the browser, and you get your C# code here under the file node, and those are your Razor views. This is the counter page. This is how the counter page Razor looks like. You can literally set a breakpoint here, let's say, and when you try executing the counter thing, it should really pause in the breakpoint, which it did, post in debugger. So you can check out local variables. You can, as you see, insert breakpoints. You can continue execution. So literally now there is C# running in the browser, and you can even debug that. So now, okay, now that this is done, we have to go back to our presentation. Sorry about this. Okay, let us pick from the point where we left it. So okay, we had our demo here. Okay, so yeah, we saw how all this works out now. Apparently, it has advantages and disadvantages. This approach allows even serverless deployment because you don't actually need a server, you just need to put the DLL somewhere, maybe on a CDN or something, and then the browser is going to execute those for you. If you use a server, it doesn't have to be a .NET server, it just serves files. There is like a minimal amount of server resources taken. Disadvantages, of course, initial download size is pretty big. Currently, it's around 2.4 megabytes for this application I just showed you, and it's that small because it gets compressed. Like the regular size is 5.4 megabytes, so it's not really useful for all scenarios. Okay, so this being said, now let's look at the other hosting model, which is Blazor Server. So this is actually quite different than the way Razor was originally used. Originally, Razor would be running in the server. You'll get a request. You'll run the Razor thing. It will generate HTML page. You'll send it back to the client side. This has changed a lot with Blazor Server. So Blazor Server is now relying on a technology called SignalR. And what SignalR does for you, it's a library that allows asynchronous notifications being sent to the client side from the server side. It was originally developed for implementing real-time web applications. It does a bunch of stuff for you in the background. It does its own connection management and whatnot. But like the really cool thing about it is it allows remote procedure calls to the client side from the server. It's like remote procedure calls in JavaScript. And Blazor Server really heavily relies on that. So the Blazor code, the Razor stuff, it's actually running on the server side, but no HTML gets sent to the client, actually. What happens is the server will actually maintain all the Razor component state in memory for the life of the session. It doesn't do this just per request. It's going to maintain this. Pretty much the server is going to maintain something like a DOM on the server side. And whenever something changes on the client, the server gets notified for that via SignalR. The server actually recomputes the DOM and it sends back to the client side via JavaScript remote procedure call. It just uses JavaScript on the client side to apply a diff of the DOM. So the server generates a diff of the DOM, it sends it to the client side, and via JavaScript it applies that. So it's not like that standard scheme where HTML gets generated to the server and pumped back to the client. So in effect, via SignalR, yeah, the server will make JavaScript calls in the client browser and modify the DOM this way. So let's try another demo. Hopefully this is gonna work better this time. Let's try getting out of the presentation. Okay, yeah, you guys see this now. So it's pretty much the same application we just saw, but now it's running on the server side. Actually, the Razor components are exactly the same. This is the same counter Razor page that was running on the client side in the browser, so code reviews is really here. And once you start it, let's see what gets loaded in the browser. So checking this out, let's reload it. And as you can see, no HTML of any kind actually gets transferred. There is some CSS, there is the JavaScript infrastructure that does the changes on the client side, and that's about it. So currently everything happens on the server. When I do this, these things get processed on the server side. So this has some apparent advantages. Oops, where did it go now? Okay. This has some apparent advantages and some disadvantages. Now you need like better hardware on the server, but you can have really thin client because the client pretty much does nothing. You also have full-fledged environment, .NET and debugging and everything on the server. But if you have network issues, then this is a problem. So let's have a really quick look at the combined hosting mode, where you have stuff running both on the server and on the client. This actually is, it's called Blazor WebAssembly ASP.NET Core hosted. So you have ASP.NET Core server and you're using Blazor WebAssembly. This reveals the full power of Blazor, because now the communication between the client and the server side uses the same technology, and it can actually, you can share code in the same solution between client and server side. So let's see how this works really quickly. So it's again that same application we just saw, and looking at the project structure, I mean, Blazor WebAssembly project is here, the Razor views are in the client-side project, then you have server-side project that, not surprisingly, just has controllers and data models. It just deals with data. And here is where the gist of it comes. You have a shared project that actually holds your data models. In this case, the weather forecasts. So now the server and the client work with the same, literally the same code for the data model. So you get compile time checks for free, you get IntelliSense for free. Like when you use this thing here, IntelliSense kicks in right away. So it's getting really efficient doing stuff this way. Okay, let's go back to our presentation. So this is what the mixed mode gives us. Now you might be wondering what's currently the performance of this whole thing. WebAssembly by design is supposed to perform not more than twice worse than native executable. So for something that runs in the browser, this is actually pretty good. C# interpreted by MonoWASM, which is the current state of affairs, could, however, be quite a lot slower than native execution of the same code. They are really working hard on direct compilation path from C# to WebAssembly, which should bring execution to within a factor of 2 as compared to native code. With Blazor Server, the performance problem could stem from SignalR and the number of connections. The current state of Blazor used to be experimental technology for quite a while, but now actually Microsoft committed to finalizing and releasing it. Blazor Server is already a first-class citizen of .NET Core. It just got released with ASP.NET Core 3.0. Blazor WebAssembly is still in preview. They are still working on this. They are still fixing stuff like the debugging in the browser and WebAssembly compilation of C# and whatnot. There are actually a couple of alternatives that are kind of taking the same approach. You might want to check them out, the Uno platform and OE. I'm not even sure how to pronounce that. So that was our trip through Blazor. That was all, guys. I'm now open to your questions. Thank you.
Okay, we already have some questions.
We do. That's
Isn't
nice.
it very unsecure to load any .NET DLL in browser? Feels like the old COM adding times.
Yeah, it is actually. I mean, it depends. You can always obfuscate these things, which also has its drawbacks, but then you have the mixed hosting mode, and you can have your sensitive logic executing on the server, and like nothing but DOM changes gets transferred to the client, and you can have like not so sensitive logic sent to the browser as DLLs. So that option is there. There is tooling to cope with this problem.
Okay, cool. The next question is, how big is a web app in Blazor and how light can it get?
Well, what you just saw, that small application with 3 pages and stuff, compiled size of this was 5.4 megabytes. As mentioned, with compression, the server uses compression to send this back. It gets cut in half. It's 2.4 megabytes, which is still not that great for a web application. They are, by they I mean Microsoft, they are really working on cutting this size further down. So we might expect it to go further down. I don't really know how successful they're going to be in this. The current state of affairs is what I just mentioned. So it's not really useful in all scenarios. Not yet.
And the last question here would be, do you know any companies who use Blazor already?
Well, having in mind that it just became official, not really. I mean, I know a lot of companies that have been researching it and playing with it, but I'm currently not aware of any real-life projects that have been started with Blazor, which doesn't mean there aren't any. But as I said, the technology really became live in September. Blazor Server became official with ASP.NET Core 3.0, which got released in September. So this is like a month ago. And Blazor WebAssembly is still experimental. So yeah, I'm assuming companies are going to start using it from this point on.
How did you get started with Blazor?
Well, as I said, I'm somewhat involved in .NET, so I'm keeping an eye on any new potential .NET technology, especially on those that might have large impact, which Blazor is. So actually, Microsoft announced it as experimental technology quite a long time ago, more than a year ago. And I'm keeping an eye on those things, so I started checking it out, and I've been keeping an eye on it ever since. But it's just out of pure interest, yeah.
Cool. We still have 2 more questions. How can we use Blazor in microservices architecture?
How can you use it in microservices architecture? Well, that is... it really depends. I mean, there is no precise answer to that. it might, I don't really know. It really depends on the scenario. It's hard to give a good answer that covers all possible scenarios.
Okay. Do you have examples of some of Blazor applications or websites?
I'm not aware of any production live websites that are implemented in Blazor yet. There is a bunch of examples on the internet for sure, but if we're talking about production quality code, I don't have this at the top of my head now, no.
Cool. Any other questions? No? Okay, then thank you very much. It was a really nice talk.
It was a pleasure. Thank you, guys.